Welcome to the deep dive. We know you're here because you love to really get into the weeds on stuff. And well, today we're going to do exactly that with something pretty out there, even for us.
It's going to challenge how we think about, well, pretty much everything.
That's good, right?
Oh, absolutely. You sent over this this paper, right? Gravity is not a force. It's synchronized motion by Dave Champagne and 01. ChatGPT, actually.
That one. Now, I'm no physicist, but even I know that's a pretty bold claim. Gravity is like the most fundamental thing, right?
It's what keeps our feet on the ground, literally.
Exactly. So what are these guys, what are they even getting at?
So motion theory, which is what they're proposing, basically says motion, and specifically structured motion, is the core building block of reality. It's not just in the universe, it is the universe.
Okay, so not just how things move, but the motion itself is the fundamental thing.
Exactly. They're saying everything, time, forces, even the particles that make up, you and me, it all boils down to this structured motion. And today we're going deep on how motion theory reimagines gravity. Forget force. They say it's all about synchronized motion.
All right, I am officially intrigued. Let's break this down for those of us who, haven't quite rewritten the laws of physics in our spare time.
Right. So first, let's level set. What do we normally think of when we hear gravity? Big objects have more of it, right? It pulls things together. And the closer you get to something massive, the stronger that pull gets.
Yeah, so like gravity 101, right? Drop an apple, it falls to the earth.
Precisely. And for centuries, we've been trying to understand how this works. Newton gave us the math, the force of attraction, then Einstein came along with general relativity, all that space-time curvature stuff.
Yeah, the whole bowling ball on a trampoline analogy.
Exactly. But motion theory steps back and asks, wait, why though? Why this attraction? Why does space-time curve? It's looking for the deeper, more fundamental cause.
Okay, and that's where synchronized motion comes in. But how do we get from an apple falling to, the entire universe dancing in sync?
So here's the core idea. It's not that mass is sending out some invisible pull force, right? Instead, motion theory says there's this natural tendency for patterns of what they call structured motion to sort of gravitate towards, no pun intended, areas of higher synchronization density.
Synchronization density. I need to unpack that one.
Okay, so imagine everything, down to the smallest particle, is constantly moving, right? But it's not random. It's highly organized, repeating patterns. And these patterns are often what they call loops.
Hold on, loops, like circles.
Yeah. Think of it as a closed, self-sustaining cycle, like a perfectly spinning gyroscope. That sustained rotation, that's a loop. Motion theory says this looping is happening everywhere at the most basic levels of reality.
Okay, a self-contained pattern of motion repeating over and over. But how does this explain, the Earth? Why aren't we all just floating off into space?
Well, think about it. The Earth isn't just a lump of rock, right? It's trillions upon trillions of atoms, all vibrating, with electrons spinning around each nucleus, protons and neutrons doing their thing, quarks even deeper down. And each of those is like a tiny little motion loop going on and on.
So it's loops all the way down.
Exactly. And here's the key. These atomic motions, as they layer on top of each other, they start to sync up. Their rhythms influence each other. They become more and more synchronized. The Earth, they're saying, acts like one giant super complex system of interlocking motion loops.
So it's not just a rock, it's like a giant orchestra of motion.
That's a great way to put it. And that synchronized motion, it's strongest at the core, creating this incredibly stable, densely synchronized zone. Now you, as a collection of your own less synchronized motion rhythms, are drawn towards that stability.
Meaning when I jump up, it's not that the Earth is pulling me back down.
It's more that your less synchronized motion is naturally drawn back to that denser, more stable rhythm of the Earth. It's like your rhythm wants to lock onto the strongest beat around.
Rhythm over mass. I like it. Now, the source talks about the Earth's core. We usually learn the molten outer core is what creates the magnetic field, right?
Right, the dynamo theory, molten iron, moving around, creating electric currents.
Yeah, where does that fit in with all this synchronized motion stuff?
Motion theory doesn't throw that out. But they say it's bigger than that. The whole Earth is involved, all the way to the inner core. That solid, spinning, crystalline core. They think it might be acting like a rhythm anchor for the whole planet.
A rhythm anchor?
Yeah, like the metronome, keeping everything in sync. If that core rhythm is solid, the whole system benefits.
Okay, I'm picturing this giant spinning crystal deep down, setting the beat for the whole planet.
And every time you jump, you're briefly breaking that synchronized connection, but the pull of that stable core rhythm brings you right back in. That's what we feel as gravity. It's a constant drive towards synchronization, this locking onto a rhythm.
So it's not just the Earth. They say we're made of these loops too, right?
Right.
Our heartbeat, our breathing, even our thoughts.
Exactly. From the tiniest particles in our atoms all the way up to how we think, motion theory says it's all loops all the way. Your heartbeat, a clear rhythm. Your breath, constantly cycling air in and out. Brain waves, electrical patterns, they loop too.
So we're like little mini Earths with all these rhythms going on inside.
In a way, yeah. And when those internal rhythms get out of whack, that's when we get sick. Or as we age, things start to break down. The loops lose their synchronization. It's all about maintaining that internal harmony.
Wow. You are motion, made of motion, interpreting motion, broadcasting motion, they say. That's a lot to take in.
It is. It's a whole new way of seeing ourselves and the universe.
And it explains why gravity is so strong up close, but gets weaker further away, right?
Think of it like ripples in a pond. Close to where the rock drops, the ripples are strong, but they get weaker as they spread out. Same idea here. When you're close to a dense, synchronized system like Earth, that synchronization is powerful. But the further you go, the more that signal fades. It gets less defined, less compelling.
So on Earth, we're in that strong, tight rhythm. But on the moon, it's weaker. And in deep space, practically non-existent.
Exactly. It's not that there's no gravity out there. It's that there's no dominant synchronized system nearby to lock onto. You're not being pulled. You're just less driven to reintegrate with a stronger rhythm.
This makes me think about gravitons. You know, those theoretical particles physicists think carry the force of gravity. Do gravitons even exist in this theory?
Motion theory says nope. They're like, why bother with a force carrier when synchronization itself explains it all? No need for gravitons, no need for curved spacetime. It's just motion seeping harmony with other motion.
Just a cosmic dance, then.
Exactly. And speaking of physics concepts, how about mass? We think of it as like how much stuff is in something. How does motion theory handle that? Well, they say mass isn't about the amount of stuff, but about how much something resists change. It's inertia. And that resistance, they say, comes from how deeply synchronized its internal motion is. Think of it like two groups of people, a perfectly synchronized marching band and just a random crowd. Which one's harder to disrupt?
The marching band, for sure. They're all moving as one.
Exactly. So in motion theory, more mass means more internal synchronization, a stronger overall motion system.
Which also means a stronger gravitational pull, because its rhythm is more powerful.
Precisely. More atoms means more internal synchronization, more mass, and a stronger tendency to draw in other motion.
Okay, one last thing. We talked about the Earth's core as a rhythm anchor for gravity. How does motion theory explain the magnetic field? Is that just the core, or is there more to it?
So science says it's the molten iron in the outer core, creating electric currents. Motion theory says, yes, but they see the magnetic field as an emergent property of the entire Earth, all those layers of structured motion, from atomic spins to the planet's rotation, all adding up.
So every atom, every bit of motion is contributing.
Exactly. It's like this giant synchronized dance, creating this ripple effect that we measure as the magnetic field. The spinning core boosts it, sure, but the whole planet is involved.
So it's not just molten iron, but the entire planet's synchronized motion, all those rhythms creating this protective field around us.
Precisely. That's their take.
Wow. This whole motion theory is, well, mind-blowing, to be honest.
Yeah.
So to sum it all up, gravity, as we feel it, is really just our own motion syncing up with the Earth's much larger, more powerful motion rhythm.
Yeah, and that magnetic field, it's not just the core doing its thing, it's the whole planet, all those synchronized motions adding up.
And the source ends on this really interesting point. It says, once you really grasp this idea, you don't just understand it intellectually, you start to harmonize with it.
Like your mind locks on to the rhythm of the universe.
It's a whole new way of seeing things.
Mm-hmm.
So as you're listening to this, think about it. If everything is really motion at its core,
Yeah.
what else might we be misunderstanding? Could things like light, inertia, even time itself be explained by this interplay of synchronized motion? It's a big question. And that, my friends, is The Deep Dive. Thanks for listening.